Hello students. Now we are going to discuss question number 7.8, and this question is talk about the question we discussed in exercise of this particular chapter 7.7. If you are using that question as a capacitor, then what they are saying there, suppose the initial charge on the capacitor in exercise 7.7, question number 7.7 is 6 millicoulomb. What is the total charge stored in the circuit initially? Means in the question is saying that solution Q value is given 6 millicoulomb. You have to convert that and mention that 6 into 10 to the power minus 3 coulomb. At the same time, some more information is needed. What is the inductance value? Not inductance, capacitor's value of that particular this questions we need that. So we collect the information from exercise 7.7. For that, what we are going to do here, they are here in exercise 7.7. It mentioned that the value of L is 27 into 10 to the power minus 3 Henry. That is the information in exercise 7.7. Now another information is there, the coulomb. Capacitance of the capacitor is C 30 into 10 to the power minus 6 Farad. And one more information, okay, so Q is there, L is there, and C is there. Now, in the question what? So these two information we got through the exercise question 7.7. Asking that what is the total energy stored in the circuit initially. A very simple question is there. We will use one formula for the initial energy, and that formula is E equal to 1 by 2 Q square by C. Keep in mind, the formula is E equal to 1 by 2 Q square by C. What you have to do, just put the value here. The first I will write the value 1 by 2 into Q value is 6 into 10 to the power minus 3. So a square is there, so I will go for the squaring of this one. Divided by C, that is the 30 into 10 to the power minus 6 Farad. Now, when we are going to solve this one, what the result will come? Into 6 into 10 to the power minus 3 into 6 into 10 to the power minus 3. What I did, just I opened the bracket and divided by 2 into 30 into 10 to the power minus 6. This minus 6, 10 to the power minus 6 going to divide to this 2. And 6 going to divide 5 times. So if you go for multiplying the lower term and dividing the higher term, the 6 by 5 2s are 10. What it will come? It will come 0.6, and it is the energy, SI unit of energy is Joule. So this one is the answer. So this formula you have to use for what purpose? You have to use this formula for calculating the energy, and E equal to half Q square C is that the energy, initial or maybe the total energy purpose, we are using the formula when in the capacitor some charge is going to be stored. Okay, na? So this way you can go through this question. Come to the second question. Friends, now we are going to solve another question, question number 7.9. This question is very easy to solve. What the question is saying that one LCR circuit is there, okay, that is connected in a series. LCR means inductance, resistance and capacitor, all three are connected in a series. Some of the value is given, and this particular circuit getting the supply, variable supply is the 200 volt, okay, and Then another information is saying that when the frequency of the supply equal to the natural frequency. See, when the two frequency are going to be equal, especially in such circuit, in that case the XL equal to XC. Okay, means inductance reactance is equal to the capacitor reactance. In such case, the what we are going to say that in that case impedance Z equal to R, resistance of the circuit. Keep in mind this information, inductance Z equal to R. We know that Z equal to what? The root under R square plus bracket XL minus XC whole square. So XL equal to XC, in that case this one is a completely zero and the result is coming Z equal to R. This one is the main information we are collecting from when the frequency of the supply is equal to the natural frequency. Okay, and of the circuit, what is the average power transfer to the second in a one complete cycle. So now the question is easier. Power supply, okay, or average power consumed by the inductance, we know that in particular LCR circuit is a zero, and average power consumed by the capacitor also the zero. So mainly the power is going to consume by the resistance. So given, so start the solution. Given, what is that the given? Value of R equal to 20 ohm is given. L value is given, that is a 1.5 Henry. Capacitor value is given 35 into 10 to the power minus 6 Faraday. This one is given in a question, and at the same time value of E given. You can say that EV is given. What is the value of EV is given? 200 volt. Okay. Now asking that in the question P equal to what? Average power supply equal to what? A very simple formula. P equal to EV, okay, into IV. If you write that for complete cycle it's talking about, that's why we need EV into IV. EV value already is there. So EV into IV value, what we have to do? We have to write EV by impedance Z. In the series connection, what is the final reactance will come? Z equal to R. Z is the impedance. So one step also. EV square by, in place of Z I can put the R by using this concept. Now it's very simple. Put down the value 200 volt whole square divided by resistance, that is a 20 ohm. Okay, now come to that another steps. This one will come 200 into 200 divided by 20. 0, 0, 2, 2 cancel. What the new result will come? 2000. Keep in mind. Because 10 times it divided, so 2000 watt will come. Why I am writing watt? Because it is the value of power. So I can write 2 kilowatt also. So average power consumed by the LCR circuit by this formula. Very simple. The only thing is that concept is there. The frequency of the supply equal to the natural frequency. If such phenomena will come, then XL and XC is equal. So impedance depends upon R. So total impedance or the total resistance provided by the circuit when this much alternating voltage is going to be supplied. By using this all the concept, I will use this formula and I will come to the result. Okay, come to the third question. Now we are going to next. Now we are going to discuss another question, question number 7.10. Okay, and this question have some concept, so I will discuss the concept, and along with that we are going to solve this question. Very easy, it's not that much tough. A radio can tune over a frequency range of a portion of MW broadcast band is given. If its LC circuit has an effective inductance of 200 microhenry, what must be the range of its variable capacitor? Okay. Question is, if you understand or not, just I will try to make you understand. Any radio is going to be listened, because of that the resonance phenomena is coming then after. Suppose the broadcasting company, they are giving a range of frequency, they are throwing in a air a one range of frequency, and that range of frequency going to match with the frequency of the any kind of radio or whatever the LC circuit. Then after you are hearing the sound, and this one is only possible when that frequency and this frequency both are equal to each other. So you can say that this question related to the phenomena of natural frequency. Phenomena of natural frequency, what we have observed that? We observed that the both the what I am talking about, reactance of the inductance and the reactance of the capacitor must be equal. In that case, we are going to understand this question. So this question is totally based on what is that? When the resonance phenomena will come. And we know that, what we know? We know that one formula, frequency Fr equal to 1 by 2 pi root under L into C. Everyone know this? Okay? Because it is the natural frequency. Now, we will move one step forward. That what we are observing, if I will square both the sides, square, and I am squaring both the sides. So what I am getting? I am getting Fr square equal to 1 by 2 pi, and this square over this root is going to be removed because the square is coming, that is a LC. Clear? Now, in the question is saying that what must be the range of variable capacitor. So I will take out the capacitor from here. So capacitor C equal to, it will be a 4 pi square. So capacitor C equal to what the new result will come? It will come 1 by Fr square into 2 pi, not 2 pi, 4 pi. 4 pi square into C. Right now. Into A. Okay. Now, if you put the value, you will get the result. But here the thing is that you are getting the two frequencies. Suppose this one is the frequency number 1 and this one is the frequency number 2. So you will get that a value or the variable range of the capacitor, one time C1 and another time is C2. So what you have to do there? Now solution. What the solution we have to do? First we have to note down what the information given in a question. Question given that F1 is the frequency, that is a 800 kilohertz. Okay, that is the first range of frequency. F2, second range of frequency, it is mentioned that 1200 kilohertz. Very nice. And inductance of this much microhenry. So L equal to 200 into 10 to the power minus 6 Henry. Asking C1 equal to what and asking C2 equal to what. We will use this formula. C1 equal to 1 by F1 whole square 4 pi into L only, because inductance have that a single value. Okay, 4 pi square. Put down the value. When we are putting the value, the answer is coming frequency. F1 is 800 kilojoule square into 4 pi square into L value is coming 200 into 10 to the power minus 6. You have to put down this value, and after putting down this value, what the result you are getting when you resolve this question, you will get some result, and that value is coming near about 100. It is coming near to 198 picofarad. This one is our first value when we are keeping that the frequency when we are going to keeping the frequency 800 square. Right? Come to that another, this one is that our first frequency, range in between C1. Now come to the C2. C2 equal to 1 by F2 whole square, 4 pi whole square into L. Okay? Same way you have to put down the value. When we are putting down the value, 1, and this time we are going to write the F2, 1200 kilowatt whole square into 4 pi square into 200 into 10 to the power minus 6. Okay, when you are going to resolve this one, what the result will come in that? What is the result is coming? Result will come 88 picofarad equal to 88 picofarad is the result. So you will get the range in between 190 picofarad to the 88 picofarad. You have to just go for the solution of this one, you will get the result. Okay, so in this way you can solve this question. Again I am talking about this question have only one concept, that the radio giving the output when the frequency sent by broadcast, whatever the broadcast MW broadcast is there, they will send the frequency, and the frequency generated by the LC circuit, if both are comes under the resonance phenomena, then after you are able to listen the sound. So for that we will use the resonance frequency formula, that is the FR equal to 1 by 2 pi root under LC. If you use this formula, automatically you will get the result. Okay, thank you.